Hi everyone, and welcome to this session on the digestive system. During the course of these sessions, we're going to learn about the digestive system, its anatomy, its function, and its importance. We're all familiar with the media images that are presented when bodies are in peak physical condition in terms of their health and their fitness. But where the systems are out of balance, the effects of this can also be noted on the body. The growing obesity epidemic is constantly in the news, and this table shows that the Western world, including the United States, the UK, Ireland, Scotland, etc., are leading the table in terms of the countries with the highest levels of obesity. In Northern Ireland, more than 1 in 2 adults are overweight or obese, and many people don't even realise they fall into this category. The Department of Health frequently launch campaigns to encourage people to consider the effect that their weight has on their overall health, including links to diabetes and cancer. Worryingly, this trend is also affecting children. It is important to bear these facts in mind, as frequently in clinic you will encounter patients with an elevated BMI, and this may have an impact on their health or may indeed be causing the problem for which they are seeking treatment. We're now going to look at the digestive system, including its structure and functions. The functions of the digestive system include ingestion, which brings food into the body, digestion, which breaks down the food, absorption, which allows the nutrients to pass into circulation, and defecation, which eliminates unusable material. The digestive system itself consists of the GI tract, gastrointestinal tract, and the accessory digestive organs. The gastrointestinal tract is essentially a continuous hollow muscular tube which passes through the body and takes up much of the abdominal cavity. The hollow part, or the lumen, is still technically exterior to the body and is lined with epithelium. It is divided into the mouth, the pharynx, the esophagus, the stomach, the small intestine and the large intestine. There are several accessory organs: the teeth, the tongue, and the salivary glands in the mouth, the liver and the gallbladder, and the pancreas. The wall of the gastrointestinal tract from the lower esophagus to the anus has a common 4-layered structure. The mucosa consists of a mucous membrane of columnar epithelium, which is in contact with the contents of the digestive tract. Underlying this is a layer of loose connective tissue, and then a thin, smooth muscle layer which creates folds in the wall when it contracts. The mucosa is also rich in lymph nodes, which play an important protective role in this major route for the entry of pathogens. The submucosa is a layer of connective tissue with a dense network, or a plexus, of neurons. The muscularis is a double layer of smooth muscle, with the inner orientated in a circular manner and the outer longitudinal. In the pharynx, upper esophagus, and external anal sphincter, the muscle is partly skeletal, as in under voluntary control. The serosa, the outer layer, is a layer of loose connective tissue bound by a simple squamous cell epithelium which lubricates the outside of the tract, and this allows easy movement of it against other body structures. The various activities of each part of the GI system are interlinked, and they are controlled by short-term nervous mechanisms and longer-term hormonal mechanisms. Digestion places a major demand on the cardiovascular system, and it takes approximately 1/4 of the cardiac output when it is actively absorbing. 3 branches of the abdominal aorta provide blood for the transport of absorbed nutrients. These include the celiac trunk to the stomach, liver and pancreas, and the superior and inferior mesenteric arteries, which take blood to the large and small intestines. We'll now look at the travel of food from the mouth through the digestive tract. Firstly, the mouth. This cavity is the start of the GI tract and contains the teeth, the tongue, and the openings of the salivary glands. The salivary glands themselves produce an alkaline watery secretion which helps to dissolve and lubricate food. It also contains a few digestive enzymes, in particular salivary amylase, which starts to hydrolyze polymeric carbohydrates like starch and glycogen to lower molecular weight products. The glands are controlled by the autonomic nervous system and are stimulated by sight, smell, taste, or thought of food. The pharynx and the esophagus are the next part of the GI system. The pharynx is a funnel-shaped connection between the mouth and the esophagus, with an opening low down anteriorly into the larynx and the respiratory system, and this is closed off by the epiglottis when swallowing food. The esophagus has an upper skeletal muscle sphincter, which is under voluntary control, and a lower smooth muscle sphincter, which is under involuntary control, and this controls movement in and out of it. Swallowing or deglutition begins as a voluntary muscle movement, but becomes involuntary as soon as the lump or bolus of food passes into the pharynx. Once in the esophagus, downward waves of contraction of the circular muscle, known as peristaltic movements, in the muscularis of the wall, squeeze the bolus towards the lower esophageal sphincter, and this opens and closes in synchrony with peristaltic waves, allowing the bolus into the stomach while preventing reflux or backing up of the acidic stomach contents into the esophagus. This diagram from your textbooks describes this process. The stomach is a very extensible J-shaped enlargement of the GI tract that sits just below the diaphragm, and it holds, mixes, and to a small extent digests food materials, which it releases only slowly into the intestines, as the digestive rate of the latter cannot normally keep up with the rate of ingestion of a meal. The gastric muscularis is unique in that it has a third obliquely oriented layer of smooth muscle, as well as the normal circular and longitudinal muscle. The gastric mucosa lies in large folds known as rugae, which stretch out flat as the stomach fills and expands. The mucosal surface is a layer of columnar epithelium which extends downwards into a large number of gastric pits with secretory gastric glands at their base. Gastric glands contain specialized endocrine cells known as G cells, and these secrete the hormone gastrin into the bloodstream, and 3 specialized exocrine cells secrete into the lumen of the stomach. So the key cell types include G cells, which secrete the hormone gastrin into the blood, and the specialized exocrine cells, which are chief cells that secrete pepsinogen. This is an inactive precursor of proteolytic digestive enzyme pepsin. Parietal cells, which secrete hydrochloric acid, and this makes the stomach very acidic, thus killing microbes in food and activating pepsinogen to pepsin. Parietal cells also secrete intrinsic factor, which is a molecule essential for the absorption of vitamin B12. Mucus cells are the third type of cells, and these secrete an alkaline mucus which protects the mucosa from damage by the stomach acid. In the presence of too much stomach acid, the stomach can become ulcerated. This is known as a gastric ulcer. Certain medications can also cause increased acidity within the stomach, and so patients may take medications which aim to reduce the levels of acidity. Digestion in the stomach is limited, and it mostly affects polymeric proteins, which are hydrolyzed to some extent by the acidic conditions of the stomach. There is very little absorption across the stomach wall, although the drugs aspirin and alcohol do move across, and this contributes to their rapid action in the body. Digestion within the stomach results in a thick, milky fluid known as chyme. A small amount of chyme is allowed into the duodenum as it has limited capacity. The stomach is usually empty 2 to 4 hours after a meal. The pancreas is an accessory organ which is compact and tapered and lies between the stomach and the small intestine. It secretes pancreatic juice into the small intestine through a duct which it shares with the bile duct. Exocrine cells secreting pancreatic juice lie in numerous small clusters or acini around the islet cells. And these islet cells secrete insulin and glucagon into the blood and are not considered part of the GI system. Pancreatic juice, of which up to 1.5 litres per day may be produced, contains a high concentration of sodium bicarbonate, and this helps to neutralize stomach acid in chyme. Several hydrolytic enzymes are also included in pancreatic juice. These include amylase, which breaks down polysaccharides, lipase, which breaks down fats, and two proteases, trypsin and chymotrypsin. Some nucleases, which break down nucleic acids, are also included. The liver is the second largest organ in the body, and its major role outside the GI tract is in the post-absorption processing of food material in the blood. But it does have important secretory and excretory functions in the GI system. It lies mostly in the upper right part of the abdominal cavity, just below the diaphragm. The functional unit of the liver is a lobule, and this consists of hepatocytes, which are the smallest cells, arranged around a central vein, and arterioles around the outside. Hepatocytes produce bile salts, which are alkaline cholesterol derivatives with a detergent-like action that helps to emulsify insoluble fats and chyme into small globules or micelles, which are available then for digestion. Bile is concentrated and stored in the gallbladder. The gallbladder itself is a smallish sac on the lower right surface of the liver, from where the common bile duct passes to join the pancreatic duct and open into the duodenum. This is opened by CCK, cholecystokinin, which we'll discuss later on in the sessions. Bile also contains the reddish pigment bilirubin, and this is a breakdown product of hemoglobin. For those of you who encounter patients complaining of gallstones, this shows an extreme case. In the next session, we'll be looking at the travel of the digestive system from the small intestine onwards.